Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. All right, guys, today we're going to continue with 3.3, part 2. The reason why we broke it up into two parts, as you saw with yesterday's homework, it takes a while to really understand this. So today we're going to focus on what's called percent change. Percent change is very, very useful. It's used in the stock market a lot. Businesses use it all the time to compare the percent of growth or decay in the products that they're selling. Football teams use it all the time. And the percent of increase or decrease of the amount of audience that they have at a game. Logistics managers for rock bands do the same thing to find the percent increase in record sales, percent decrease. This way they know who's hot, on the market, who's going down already. Business uses it all the time. So percent change, literally, okay, is defined as the new value minus the old value times 100. Now, let me explain a little bit about this. This right here is just symbols, fancy symbol, guys. That's percent, okay, this guy's percent. And this triangle here, there's a Greek letter called delta, and delta stands for change in science, okay? So percent delta really just means percent change. And like I said, it's talking about the new value minus the old value divided by the old value times 100. We multiply it by 100 because we want to turn it into a percent. And remember that we're going from decimal to percent. You're moving two places to the right. So if you're moving two places to the right, that means you multiplied by 100. Does that make sense so far, guys? Okay, you with me? All right, so let's take a look at it. Number one, a coat is on sale. The original price of the coat is $82. The sale price is $73. What is the discount expressed as a percent change? Okay, in this particular case, we have an old price and a new price. The old price is not necessarily always the largest. The new price is the most recent. The old price is, of course, the oldest one. So the original price in this case would be the old price. The new price is the sale price, right? So I have my new value of 73 minus my old value of 82 divided by my old value of 82. Does that make sense to everybody? Yeah? You with me there? Okay, so now this is pretty simple. 73 minus 82 is going to be -9. That's fantastic. Over 82. And now when we go ahead and do that division, we're going to have -0.1097, which is basically -0.11, which equals an 11% decrease. Now, some of you may say, whoa, wait a second, Mr. Moore. What happened to the negative? Where did it go? Well, the negative is just there to show you guys that this is a decrease, that it went down, okay? You can't really work with negative percents. You can only work with positive percents. So even though this was a -11, that just means that it went down 11%. Yes, sir. I did. This 0.11, I went 1, 2 to the right, which is the same as multiplying by 100. Thank you for asking, sir. God bless you. Good job. Does that make sense, guys? Now, yes, sir. You could use the word decrease if you so choose. Okay. Thank you, my man. Does that make sense, guys? All right. So now, a store buys an electric guitar for $295. The store then marks up the price of the guitar to $340. What is the markup expressed as a percent change? Okay. In this particular case, we're going to again use my formula. What is my new price here? $340. So in this case, the new price is larger. And what was my old price? $295. That's exactly correct. Excellent. Divided by my old price of No, my old price of, oh yeah, of $2.95. That's exactly right. Great job. Excellent. Okay, so 340 minus 295. Yeah, actually, yeah, 45. Excellent. Divided by 295. Now, I've got a little trick for you guys. I know that this kind of division is tedious, it's long, right? But don't both numbers end in 5? So can I make my life easier by dividing everything by 5 right off the bat? And that's going to be 9. And then 9 goes into 20. 5 goes into 25 times. So 59. Does that make sense? And then it makes your life a little bit easier. Okay? And then, of course, we're going to go ahead and divide it. So 9 divided by 59 will equal 0.152. So 2 places to the right because I multiplied by 100. And we'll go ahead and say 15% because I wanted rounded to the nearest percent. Yeah, I should have put an increase there. Absolutely. Thank you, my man. Great job. As always. Does that make sense? Questions, problems, concerns? Anything? Yes, sir. Yes, you always want to write whether it's an increase or a decrease so that the reader knows. Thank you. Excellent question. Continue? We good? All right, boys. Number 3. The stock price started the week on Monday valued at $32.15, right? Then by the end of the week on Friday, the stock was valued at $29.38. Find the percent change in the value of the stock. Okay. What do I do? Yes, sir. Maximo. New minus old. No. New minus old. Think about it. Who's newer, Monday or Friday? No, guys. If I'm already in the weekend, Friday is the newest day, right? So it's going to be 29.38 new minus old of 32.15 divided by old 32.15. And of course, times 100. Does that make sense? So I heard that. Oh, which I love it. That means we're learning. Does that make sense, gentlemen? Promise? Okay. Now, what do we got here? 29.38 minus 32.15, right? So that's going to give me negative 2.77 divided by 32.15, which gives me 0.086, negative 0.086. So that's going to be 1, 2 to the right because I multiplied by 100. So that's going to be 9%, and it was a negative. So it's a 9% decrease. I know the numbers are not pretty, but does it make sense, guys? Okay. So anytime they're asking you for percent change, you can use this formula. New minus old divided by old. If it's negative, it's a decrease. If it's positive, it's an increase. Does it make sense? All right, brothers. Let's do one more. As you can see, I want to make sure I really drive this point home. In 1956, there were 415 students enrolled in ABC High School. Okay. Today, some 60 years later, there are 1,828 students enrolled in ABC High School. Find the percent change of enrollment. Who wants to set it up for me? Oh, let's go, baby. Let's do it. You got this. Come on. Nice. All right, man. I'm proud of you guys. You're doing well. Okay, my man is going to start here with new, which is 1,828 students, minus old. Fantastic. There were, 60 years ago, 415 students. Excellent. Excellent, brother. Give me 5. Good job. Now, I'll help you out real quick here. Now, let's just do the math, right? So we got 1828 minus 415 So I've got 1,413 divided by 415. Now let's go ahead and just, I'm going to cheat a little bit here. Use the calculator just for speed's sake. And we've got 415. So that's going to equal 3.40. Now I got to multiply it by 100 because I have to turn this decimal to a percent. So I go 1, 2 places to the right. So that's 340% increase. That makes sense. As populations grow, you know, more kids have to go to school and everything grows. So communities, you know, apartment buildings, malls, everything grows. Does that make sense, y'all? Excellent. May I continue? All right. Now, I know you're probably saying another one. Yeah, I want to make sure that you guys understand this. This is not super common, but I have seen it on the SAT and the ACT. So why wouldn't I show you so you guys at least have an awareness of it, okay? And it's called relative error. All right. Relative error is a quite interesting concept. Relative error occurs when things are manufactured, okay? As precise as we can make machines and machinery and cuts and molds, there's always a little tiny bit of possible relative error. For example, I like to build a lot of things, okay? So a little bit of a handyman. So what I'll do is if I have to go do something for my house, you know, for example, I once had to replace the baseboards of my house. So I needed the correct amount of length of baseboard, right? So I never forget, they were selling these sheets of baseboard, and they were 8 feet long. Now, of course, Mr. Morrow went with a measuring tape. And when I went ahead and measured the board, it was not 12 feet long. It was actually 11 feet and 9/16 of an inch long. So it was a little bit short. So that's what I mean by relative error. In a cereal box, they'll say 16 ounces. I guarantee you, if you went ahead and weighed about 1,000 of those boxes, not all of them would be 16 ounces. Some of them would be maybe 16.01. Some of them would maybe be 15.98. But not all of them will be exactly 16. So that is what relative error is, okay? And it's important to know, again, for many business applications. And the formula is the goal or estimated value, okay, what it should be, basically, what it should be. This goal or estimated value is what it should be minus the actual, minus what it is, okay? And I always tell you guys it is what it is. Well, it's what it should be minus what it is divided by what it is. Okay? So let's think about this. We have a decorator estimates that a rectangular rug 5 feet is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? First of all, we always have to read. Sometimes people will start breaking this down and go length with length and width with width. You can, but I wouldn't because it said area, right? So what happens here is let's first find the area of the estimates or what it should be. It should be an area of 40. Very good. Thank you, my brothers. 40 square feet to be precise and exact. Now, what is it? It is 32. Now that we have my should be and is, let's just plug it into the formula, y'all. So my formula for relative error is, oh, sorry about that. My formula for relative error is what it should be, 40, minus what it is, divided by what it is. So this is 8 over 32, which is 1/4, and that's 0.25, which equals 25% error. So there is a 25% error on the area there. That's huge, guys. Let's say that you were building a hotel, okay, or condominiums, and you were putting all of these rugs at the entranceways of all the different units. That's a lot of money that we're losing. You're using 25% of actual rug, but yet you're still paying 100% of the price, aren't you? That's where relative error comes in handy. You know how much you're losing or gaining, okay? Does that make sense? Questions on this? So remember, with this guy, it's what it should be minus what it is divided by what it is. And last but not least, we got a quality control inspector. Randomly chooses serial boxes in order to inspect the boxes for damage, okay? And for proper dimensions and weight. If the allowable error is 1.3% for weight discrepancies, what will a box weigh? Will a box that weighs 17.1 ounces pass if the estimated weight of each cereal is 16 ounces? What do you guys think we would do here? How would I test if this was right? You're the quality control guy. You get paid a lot of money, by the way, for this job. It's a very good job, quality control specialist. You're getting paid a lot of money. You can have an allowable of 1.3%. How do you know if this cuts the mustard or not? Yes, sir. No, but good try. Thank you for asking, sir. You have an allowable error of 1.3%. What do you think, guys? Yes, sir. Okay, how would you do it, though? No. Okay. Yes, sir. Thank you. Say it, say it, say it. Come on, be proud of yourself. I'm proud of you. You multiply the percent to the, no, to what it is. I'm sorry, to what it should be. And then add it to see if it gives you what it is. So for a great job, Deshae, I'm proud of you. So look, guys, you got 16. You got 1 to the left. So times 0.013. So I've got 8170 skip 310. So I got 8012 123 123. So 0.208. That's my allowable. That's my allowable error. Does that make sense? Promise? So what's 16 plus 0.208? 16.208. Is this allowable? Will this pass? Hell no. They will reject that one. That's the way business goes. Does that make sense, guys? Sir, my brother. It's not necessarily an example of the equation per se, but it's an example of the application of it, right? Yes, of course I can. Thank you, my man. I multiply 1.3 to 16 because you have a 1.3% allowable discrepancy. So 1.3% of 16 is 0.208. So I can either add 0.208 or subtract 0.208 from 16, and it will be an allowable weight. Does that make sense, guys? Thank you for asking. Great question. We're good? Yes, sir. If it was, okay, if it was between, let's go 16 minus, let's go 16 minus 0.208. We got 2. Okay, so if the value, or the weight of the value rather, the weight of the cereal box was between 15.792 and 16.208, it will be acceptable because you have a 1.3% allowable error. So you have to find what this 1.3% is. Then you add it to it and subtract it from the original. And that gives you my allowable weights. Does that make sense, my brother? Thank you for your honesty. Anything else, guys? All righty. Thank you. Hope you learned a lot. Have a good day, brothers.